factoring by grouping. And in order to understand this, you have to kind of think about this. What if you have this? X plus 8, and I'm multiplying it by 7, I'm sorry, let's go with the letter M minus 3. If I'm multiplying though, let's multiply those together first. What do I get if I multiply that together? Anybody? How would I multiply that together? Now, yes, you're saying FOIL. Somebody say FOIL.
FOIL.
Okay. You can use FOIL, except for the thought is this, you're not going to get these two middle terms like with normal, if this was an X, would combine, but now they're not going to, because watch. The two first terms, X times M is XM. The two outside terms, minus 3X. The two inside terms is plus 8M. And the two last terms give you minus 24. Correct? Nothing combines, nothing simplifies. This is your answer. Now, what you really did, and this is the important thing to think about for what we're doing tonight. What you really did, if you break this apart, and if you break FOIL apart, is you took X, and I multiplied it by both of those, right? Sorry. I took X and multiplied by M minus 3. Because first term was X times M, the second term was this negative 3X. So I did that. Right? And to that, I multiplied 8 times both of those. Distributive property with the 8. 8 times M, 8 times negative 3. Okay? Because you are going to start with this and look to see if you can get it to look like this, because if you get it to look like this, you're going to be able to write this as two binomials, x plus 8 times m minus 3. If you can get in a parenthesis the exact same term, you can rewrite it like this, like we started off with, which may or may not make any sense to you. It doesn't really need to make sense to you because this is what it will look like. Ready? I should do that one. Let's do the one I had up there. Okay. This is called factoring by grouping, which means you try to group together. You always look to see if you can take something out of everything, but there's nothing, right? I can't take any. They don't all have ends, and you can't divide them all by 2 or whatever. So if you ever come up to a 4-term thing, this is the only way that you can do it, is to factor by grouping. But you still look to see if you can factor something out of all 4 terms, which I can't. So now I'm left with my only option is to try to factor by grouping. And what that means is you group these first 2 together, and you group the second 2 together. Don't do that because it's not multiplication. And you look at that and you say, can I take something out of just these 2? Do these 2 have anything in common? What can you take out of both of these? N squared and 3. So if I take a 3n squared out, what am I left with? A 3n, right? And a 3 times 1 gives me negative 12 minus 4. Okay? Then I do the same thing over here. And you do that with the hopes that in parentheses you'll get another 3n minus 4, because if you do, then you can rewrite it as 2 binomials times themselves. Well, what can I take out of both of these? Actually, I hope this works. It doesn't affect the more problem. There might have been a problem here, but it couldn't affect. What can I take out? A 2. Should I take out a negative 2? Let me make sure I wrote this down right first. Maybe you are correct. Oh, it should be plus 6n, by the way. That's fine. I can say this wouldn't look like it was going to work. I put the plus there. I'm going to take a 2 out. If I take a 2 out, I should put a plus 2 there. What am I left with? A 3n minus 4. If that happens, then you keep just one of the 3n minus 4s, put in parentheses, and you pull out the front of this and the front of that, and that becomes your other parenthesis binomial. Because that's the same thing we just did with that last problem, which is backwards. If you come up with the same thing in parentheses, you can take it, because that's just reverse distributive property. Right, took out the 3 and multiplied by that. That is factoring by grouping in its whatever nutshell. Let me give you another one. Let me find one that's really super easy one. How about, let's just do this one. X cubed plus 4x squared plus 2x plus 8. Again, the first thing you do is look, can I factor the same thing out of anything out of all 4? I can't. Okay. Can I group them and factor something out of each group? Sure, let's try. If I put these two together, what can I take out of those? An x squared. And if I take an x squared out, it's x plus 4, right? Now I'm hoping to get an x plus 4 in the parentheses on the other one too. What can I take out of these two? A 2. And what am I left with? X plus 4. So if that's the case, then I can rewrite this as x squared plus 2 times x plus 4. Now, you can also, Caleb Cook, if you have to and would like to, you can rearrange the order of these. If you look at it and you can't factor it, you can always change the order to something that you could. For example, let me copy this and just, no, let me do this, no, let me just draw over top of this. Let's say I wanted to change the order of it. And you want to group things you know for sure that you can factor things out of. Let's say I put the 2x, let's say I went x cubed plus 2x. I just moved the 2x over here and put the 4x squared over there. 4x squared plus 8. And I factored it by grouping here. What can I take out of this? An x. What am I left with? X squared plus 2. I'm hoping to get an x squared plus 2 over there. What can I take out of this? A 4, which would be x squared plus 2. What do I get if I put it back into its two binomials? The two front things get grouped together, and then the x squared plus 2 groups together, which I believe is the same thing I got, right? The last one? Oh. You say give me another. Right here, let's do a hard one, David, because David's getting a little bored. Okay, I'm sorry. Sorry, Caleb. Of all your brothers, which one would you rather I call you? I could probably make that happen. Not even Josh. This, by the way, is the hardest one on the paper. I know you want to be challenged. Now, let me tell you, never, ever, ever, ever forget, Caitlin Stritzel, rule number 1, which is to do what? Take out any common factor that they all have. Can you take something out of all 4 of them? An 8? Anything else?
What's
Any letters?
First? Yeah. 7?
That's a 40.
Oh.
What does it look like? B?
Yeah.
Oh, I would be
What's that second one? Is that an 8
It's an
or an
8.
8? Okay.
Really? Is my handwriting that poor?
You know,
I can take it.
Mouse.
I believe an 8.
Just
I believe an 8 is the only thing that comes out. So when you do that, you're left with a 6ac squared minus yd squared minus 2ad squared plus 3yc squared. And that 8 has to stay on the outside. In your answer, there will be an 8 sitting out there because we're factoring this. Now, if you look at this, and here's where you go, I see an issue here.
I see an issue.
If I try to put these two together, do they have any common factors? No, but this one has an A, and this one has an A, or this one and this one have a D squared, or this and this have C squareds. You can rearrange it in any order you want, and I think as long as you get something to be factored out, you can get it. What should I do? Anybody? What would you like me to do? Which ones would you like me to switch around? What order? Grace Watson. What would you like to do? Let's do that. Oh, golly. Let's see what happens. So I can do 6ac squared. I'm going to move this one here. So that means then I'm left with a minus yd squared minus 2ad squared over there, right? Yes, let's see. Let's change colors because it looks so much nicer. So, keeping my 8 out there, I'll just put in parentheses. What can I take out of both of those? 3c squared, right? Am I correct on that or not? So I'm left with a 2a here, right? Plus a y. Am I right or am I right? So, again, your goal is to get a 2a plus y in a parenthesis over here. So here's where you got to do a little bit of thinking here. These are both negatives. So in order to make them positives, I'm going to have to take what out? A negative. What do they both have? So I'm going to take a negative d squared out, which is going to make this a positive y, and it's going to make this a positive 2a. And then you're going to have to recognize, are those the same? Yeah, they are. Just you can flip-flop it. Because of the commutative property of addition, 2a plus y can be switched around there. So what does the whole thing look like when we're all done? You've got this 8 on the outside. You can put this and this together in a parenthesis because they're multiplying by the same thing on the other parenthesis. 3c squared minus d squared. And then in that parenthesis there we get 2a plus 1. Welcome to some upper level mathematics. You get this and you very possibly could get 253.6. How many people at least remotely think they get this? Oh, that is not. You are just bonkers. That's the hardest problem on there. Here, let's try one more. Maybe I should give you. Let me give you the sheet. Fractions by grouping. I don't actually get. You guys are getting close to farther than any class I've ever gotten. Close.
That's good.
If we get to the quadratic formula.
Is that next?
I told you what it was. What was it?
Try to reach on here.
Negative b plus or minus the square root of 4ac minus b over Now I'm not going to be
Do we need an extra one? So who?
Let's see. Fire Marco, pick a number between 1 and 26. Without looking. Number 17. I would like for you to try number 17, which looks like this. 6xy minus 6x minus 5y squared plus 5y. And your job is to give it a shot. You never know how much you know until you try what you don't know. Everybody done yet? Oh, I saw that. It's the same book you did tomorrow when you guys people watch this. because you're taking out the same thing that this is, you're still left with a 1. And you want, and here's where you have to think a little bit here. You want the y to be positive, so you're going to have to take a negative out of that to make it its opposite. So I'm going to subtract a negative 5 out of that and a y. Which, if I do that, I'm left with a y minus 1.
Convince us, Andy.
So you should have ended up with 6x minus 5y and y minus 1. How many people got it?
I don't do David.
I get a paper.
It's actually
No, it's not hard, but it is confusing. Yes, definitely explain. Here we go, another one. I will walk you through it. David, pick a number between 1 and 26.
17.
25.
Oh,
David, for your sake, pick a lower number. I think everybody else, but 16. You do 16? Here. Alright, those of you that just came in.
We're not gonna have to do sugar content.
Who, you?
Maybe.
Who else are you doing with? Those of you that just came in, here we go. In fast speed, it's always good to review here. First thing you do is, you're trying to factor this. And you'll notice it's a little different than everything we've done before because there's actually 4 terms, not 3. Okay? So, and the only way to factor a 4-term thing is to do it what's called by grouping. And you start out with the same thing and say, can I take the same thing out of all 4 terms? Do they have any common factors? This one does not. Can't take any of the same number, they don't all any have the same letters. If that's the case, then what you look to do is to group 2 of them together and the other 2 together and see if you can't factor each group by something. So what do both of these have, Ryan Connor? And a 5. So you take that 5u out, which I'm going to write down here, and I'm left with a v plus what? 2u squared, right? 2u cubed. Sorry. Now you are hoping, those of you that just walked in, that when you factor the other one, you get this same factor here, because if you do, it's very special. What can I take out of these 2? Oh, I can't. Ooh, you stumbled upon a good one. Somebody, what do I do? You can actually take something out. What would you take out, Maggie? Oh, you take a negative 1 out. Don't do the negative, because you want that negative 1 to be there. If you take a negative 1 out, what does this change this to? A positive v and a positive 2u cubed. If when you do this, those of you that just came in, you end up with the same factor here, okay? If you end up with that same factor there, you keep that same factor, and you put the 2 front things together as the other factor. Because really, what we just did there was reverse distributive property. Because you do this times this group gives you this, you do this times that group gives you that. So this is that factor.
Oh, that was a lot of confusion.
Yeah, no, everything looks a lot. Now, let's do David's, the one David said.
Yes.
Look at all the numbers there, David.
Yeah, no, you're right. Yeah.
94
24 and then 23. That's
A5C plus 288 A4X D squared. I don't think I have enough room to write this up there. Minus 252 D5D squared minus beta what? I missed one?
Oh, no, you spelled wrong. It's 8 of
And then
not
v
X.
squared
You said D.
A to the fifth what?
D squared minus 336. A to the fourth.
XC.
Yeah.
We're almost done.
Do they have, yes, they do have some common factors here. First of all, they all look like they have an A something, right? What is it?
A.
So we can take an A to the fourth out. Do they all have C's? No. Do they all have D's? No. Now, what about common numerical factors?
They all have two.
Something. Well, they are all even, so you could take a 2 out. Does 3 go into all of them?
Eight.
Yes. So if they're factorable by both 2 and 3, that means they're factorable by 6. Should we take the 6 out? I'm gonna look at 6 and 8.
If they're factorable by 6, they should be 9.
No, if they add up to 9, you can go all.
No.
11, 15, no, 9 doesn't go into that.
You're going to lose before.
Let's try 6. 6 is what? 49. 6 is 43. No. 24, 48, 48. 6 is 43. And 6 is 56. And those are not, don't have any common factors, right?
Knowledge.
Okay, so I'm taking out a 6A to the 4th. What am I left with? 49AC. Who asked for this one?
David. All David.
Plus 48XD squared minus 43A D squared minus 56XC. Is that what you got?
That's exactly it.
I just took out a common factor, which is high numbers because David picked this problem. Anyway, that's yours.
Yeah.
Yeah.
True. Now, if you look at that though, and here's for those of you that just came in, if I attempt to do this whole grouping factoring thing and I look at this, there are no common factors there. Okay? But because of the commutative property of addition, you are allowed to rearrange these terms so that there is something. AC, is there any other term that has an A or a C in it? Either one of these two, and I don't think it really matters which one you put next to it, but I'm going to scooch one. Let's scooch this one just because. So I'm going to rewrite this. 49AC, put this one next to it, minus 43AD squared. Keep that one there. 48XD squared minus 56XC. I just moved those two terms.
So where'd you get
Did I do something wrong?
49C squared?
Oh.
It's just
Wait, and wait, where's the
Wait, what happened?
It's 49.
AC.
And why is there
There's no 9.
Wait, it's the A.
Wait, what did I do?
It's supposed to be
It's
49.
supposed to be 9.
And
It
that
looks
looks
like
like 4.
Honestly. Okay, 49AC. So if I factor something, what can I take out of those two? They both have an A, right? Yes. So if I take an A out, I'm left with the 49, the C, plus 48. Did I take out the A? Wow. You might get any homework at all if I keep going this way. D squared. You better hope I'm failing. So let me tell you what you're looking for. You hope, which ain't gonna happen because there's not even close to the same numbers there. You hope, oh wait, we hope to get a 49 and a 43 over there. And I'm not seeing it happening. Anybody seeing it happening? You might. I'm thinking I wrote something down wrong, but I'm too far into this to change. I far into this.
You were put 49 and 56.
Ooh, is this supposed to be 56?
What if you do
No,
like
what if you
that?
did 49?
Is this supposed to be 6?
No, like the far term over there.
Is this supposed to be 6?
That one, if you
No, it's just like you moved over
How about we
to
just
minus
have
40,
that
80,
one?
and
I don't think
then
we mind that.
We can make this better money.
I am going to redo this whole video tomorrow,
Really?
for those of you on the campus.
Maybe me, so I know it's more.
Yes.
How about this? If you want extra credit, I will let you do, because I'm sure I did, I'm sure I either wrote something down wrong or divided wrong somewhere up here that this did not work out, because I'm betting it does work out. If you want extra credit, you can bring me this problem corrected on my desk by tomorrow morning.
How much extra credit?